All right, so we're going to look at simplifying cube roots. We've simplified and factored square roots, right? So now we're going to look at cube roots, and it's very similar to what we've already done. All right, so if we're going to simplify cubed root of 54, I keep hitting okay, so there's my factor tree. What can I factor? How can I factor 54? 9 and 6? Okay, but then I can continue to factor those guys, right? What's next? How can I factor 9? So 3 and 3? What about 6? 3 and 2. All right. Yeah. It doesn't really matter. Position doesn't matter on here. Okay, so do I see any groups of 3? What do I have? I have 3 3s, right? So that's a cubed root, right? 3 times 3 times 3. So I'm going to pull out my 3 and leave my remainder or my leftovers inside. If I had another number, I would multiply them and put their sum inside, right? So let's look at another example. How about this one? I can still factor it out, right? This time, instead of looking for sets of 2, I'm looking for a set of 3. So what can I use to factor out 128? Is it a perfect cube? No, so I'm going to have to factor it out, right? What would I take? How about 64 and 2? Would that work? Can I continue to, I can't simplify 2 anymore, right?
Yeah.
But what about 64?
64.
6 and 4? 6 times 4 is 24. 8 and 8?
Oh yeah, 6 and 8. My bad.
8 and 8, right? So then I can still factor out my 8s, right?
Yeah.
So I'll do 1 first, and what do I get? 2 and 4? What about my next 8 again? 4 and 2. Okay, now I'm going to look for a set of 3. Do I have 3 4s? No. How about my 2s? I have 3 2s, so I can pull the 2 out, and then what I'm left with, oh wait, I can still factor my 2s, what am I saying, right? 2 and 2. And what about this other 4? So now, let's look for sets of 3. I've got a set of 3 here, and a set of 2 here, another 2 here, and another 2 here. So I have 2 sets, right? So I'm going to pull both of those out, but I have to multiply them together outside of my root. So I'm going to do 2 times 2 square root 2. Which ends up being 4 cube root, not square root. Yes?
That's where after, how do you know where, like, which is square and which is...
Well, they're all cubes.
Yeah, you have the two in the middle, like, so like whenever you have pairs of that goes.
Yeah, well, it depends on the number here. So if it's the 3 here, I'm looking for a cube root. If it's not a 3 here, then I'm looking for a square root. It could also be a 4 here, right? You had a 4 in your homework, so you had to figure out what multiplied by itself 4 times to get that number. Okay, so let's go backwards. We're going to rewrite it. So this time, I'm going to rewrite it as, 4 times 4 times 2. That's going to go underneath my hat. I get square root of 32, right? So if I started with the square root of 32 and I factored it out, I would have ended up with 4 times 4 times 2. 4 square root 2. Let's look at another example. 6 square root 3. So this means 6 times 6, right? If it's outside, it's 6 times 6, correct? Do you understand that it's 6 times 6 when I put it under my hat? I'm looking for from affirmation. If my 6 is outside and I'm going backwards, when I move it inside the radical sign, it's going to be 6 times 6, correct? You guys understand that? So my next move will be 6 times 6 times 3, because there's also a 3 already under there, and I'm multiplying everything. You writing this down, Dominic? That would be a no. So 6 times 6 is what? What is it? I hear a mouse somewhere. Loud and proud, Clarissa. What is it? It's 36. So then what is 36 times 3? I'm sorry, Isaac. What was the answer you said again? 108. It's 108. Thank you. Sorry. So the answer is 108. Okay, radical. So that's going backwards. So if I give you a radical like this and I tell you to give me an exact answer, you're going to do the backwards of this and end up with 6 radical 2. If I give you this and I tell you to give me the radical answer, you're going to go backwards and give me this. Do you understand? There's 2 different ways to answer this question. You have to be really careful when you're actually doing your assignment that you understand what is being asked of you. And that's where a lot of you guys really struggle, is you don't read the directions, and then you come up here and you say, what was I supposed to do? All right, so I'm going to have you guys do this one on your own. You're going to go backwards, and you're going to give me the radical answer for 2 cube root 5. Go. That's an admirable job that he's doing. Oops. All right, guys, so then who got that? Raise your hand if that's what you have. All right, so that's the backwards version of what we did yesterday, or the factoring the other day. And this is also including cube roots in there. Right? Did you get that, Saul? All right. This time, I want you to tell me if it's less than, greater than, or equal to. So we're going to figure out what is the square, what is 4 squared? What is it?
8.
No, 4 times 2 is 8. I want to know what 4 squared is. 4 squared is 4 times 4. So what is it? 16. So what is 3 cubed? Excellent. It's not 9. It's not 3 times 3. 9 times 3 is, what's 9 times 3?
Oh, okay. Okay.
You have to pay attention to the exponent, okay? All right, so which one's bigger? So which one of these am I going to use?
The first one you're going to do greater than the first one.
The first one, because 27 is greater. So you want your wider opening with your bigger number. I don't talk alligators in junior high anymore. Yeah, this is greater than. Or this is actually less than. Less than. This is greater than, and this is equal. Okay, we don't talk alligators anymore. All right, go ahead and try these two. Oop. I just gave you the answer. Go ahead and do these on your own. Do these on your own.
Yeah, gotcha.
Which one's bigger? Greater than, less than? First you have to tell me what the whole number is, and then you have to tell me which one's greater than, less than, or equal. All right, so you guys got an answer? What do we get? Isaac, what did you get? For what? For this one? This is what? How'd you get, I'm asking you to tell me which is greater than, equal to, or less than. Huh? The one on the right is, well, what is this answer here? No. It's not -5. This answer here? What is the cube root of 64? You should, because you have it on your sheet. Karina, what is the cube root of -64? It is -4. Excellent. What is the negative squared root of 25? Karina? It's -1 times 5, which is -5. Right? So now, which number is greater? Which one? -4. So I'm going to have a greater than symbol here. Wait, what? What do you mean no? 4 is on the right of 5. -4 is on the right side of -5 on that number line. So the numbers to the right get bigger. Okay? Why are you confused, so? I'm sorry? I've got -4 from here. It's on your note card. Look at the cube root 64. What is the cube root of 64? Cubed root. Right. So it's negative inside. So it means my answer is going to be -4. If this was just 64, it would be positive or negative, right? -4. Scary, guys. All right. We're going to find the length of side S. Okay, so Ryan, you just asked me why is everything S? Because it's a square. What do we know about a square? They're all the same, right? It has 4 equal sides, right? So this means the length, the width, and the height of this 3-dimensional square are all going to be the same number, right? So if it tells me that the volume is 27, when I do my equation, length times width times height, what are these 3 numbers? Are they all going to be the what? Different? Or are they going to be the same? Because what's my length? S. What's my width? S. What's my height? S. So I'm going to do S times S times S, right? So if I'm really looking for the cube root of 27, right? It's going to be S times S times S, correct? What's the cube root of 27? What is it? So S cubed is 27. If I take the cube root, my 3's cancel. S is equal to 3 times 3 times 3. S is equal to 3. Does that make sense? Okay, I'm really just looking for my cube root of 27. Right? David, you're not helping matters. Does that make sense to you guys? Do you understand what we did here? It's a box. All the sides are the same. My volume is 27. The equation I use for finding volume of a cube is length times width times height. Right? If all my sides are the same, it's going to be S times S times S, which is a cube, right? Is the same as S cubed. If I take the cube root of S cubed and the cube root of 27, these cubes are going to cancel. It's going to give me S is equal to the cube root of 27. Okay? I can say 3 times 3 times 3 is 27, which means S is equal to 3. Right? Yes? 3 feet. All right, here's one more. Huh? What? Yikes. Not really. Okay, so write the equation. Length times width times height equals the volume. You don't have to draw the picture because cubes are hard to draw. Write the equation down. What do I know my sides are? S times S times S, right? So write that equation. What is S times S times S the same as? S cubed, right? So then I know that S cubed, what's it going to equal? What's my volume? So throw 125 in there now. Yes? Okay, now you're going to take the cubed root, which means when I say take the cubed root, you're going to add that cubed root, that radical in the cube, over both. Because remember, it's still a scale and it still has to be balanced. So if I'm going to add this cube root on this side, I also have to add that cube root on the right side. It still has to remain balanced. Everything still applies. Whatever you do to one side of the equal sign, you have to do to the other. So now that I have this cube and this cube, they're going to cancel each other out, right? So I'm going to go ahead, I'm going to cross out my cubes on the left side only. So now I just have S, right? That gives me just S on this side. We're still solving an equation. We're still doing it vertically down. It just looks a little different. But now I'm going to look at my note card, and what is the cube root of 125? What is it?
5.
It's 5, right? So S is equal to 5 times 5 times 5, which means that S equals 5. Understand?
Yes.
Any questions, Saul? Here's your opportunity to ask. You understand? Okay, so your homework is out of the book. Write it down. No, actually, just 3 through 14. Don't write that down. You're doing